In this video, I'm going to show you the Excel skills for section 6.2 in your book, which is constructing a confidence interval about the mean. So the first thing we need to do is make sure we know all of our values. So our sample size n, they tell us, is 14. We're studying 14 bowlers. So right away we know our degrees of freedom, which is n minus 1, is 13. Then we need to make sure we know x bar. Sometimes you'll be given a set of data and you'll have to type in all of the data and then use the average function in Excel to find the x bar. But in this problem they tell us the average is 192, so I'm just going to type that in. Then we also need to know s. S is our sample standard deviation, so if we were given a set of data, we would have to use the stdev.s function to find it, but in this case we're told that the sample standard deviation is 8. So now we're ready to find our critical value, TC. So TC, we use the Excel function t.inverse.2t. So I'm going to go up to Function Wizard, go down to Statistical, and go down to t.inverse.2t. And the probability that we put in is the area of the two tells combined. So if we're visualizing the graph that goes along with this, we have our bell graph, which is our t-distribution, and we put the 98% confidence in the middle. The probability that we're talking about here for this t.inverse.2t function is the area of everything left over in those two tells combined, which is 2%. So we're going to put in 0.02 for our probability. That's the area of the two tells together. And then our degrees of freedom we said was 13. So our TC is 2.6503. So next we calculate our margin of error, and that's given by our TC, which I'm going to use to 4 decimal places, times our sample standard deviation divided by the square root of our sample size. And the biggest mistake I see students when they type in this formula is they divide by the square root of the degrees of freedom instead of the square root of the sample size. And it's a silly little typo, but for some reason I see it all the time. So just be careful that when you're typing in your margin of error formula, you do the square root of your sample size. So here we have 2.6503 times 8 divided by the square root of 14. And then all we have to do is add and subtract to get our endpoints. So our lower endpoint is going to be our x bar minus our margin of error. And then our upper endpoint is our x bar plus our margin of error. So what this is saying, let me type this out in the text box so it looks nice. What this is saying is that we are 98% confident that the population mean bowling score is between a 186.3 and a 197.7. So we're 98% confident that the population mean bowling score is between 186.3 and 197.7, which that's a really good bowling score. I know the last time I went bowling, I was not anywhere near that. So these bowlers must be really good. And what you'll notice about this section is that there's a lot of typing and little calculations, but it's very algorithmic. If you're somebody that likes a process where you just follow the process, you do step 1, step 2, step 3, and repeat, you're going to really like this section because we're just doing the same process over and over, and once you do it a couple times, you'll have it down pat. And the good news is you do have your note card for the next test, so you can write down each step. You can label yourself step 1, do this, step 2, do that, and that way on the test you can just follow your steps and get through the problem.